rational inequalities are more like higher power inequalities than they are linear inequalities, in that I can't just solve it out. What I first need to find are what's called the critical values, which occur not when it's less than or equal to, but just at the equality, when it happens to be equals one critical number, because that's going to be a change in behavior between less than and greater than. And the other one is when any of the expressions are undefined. So rational inequalities is actually going to, because it's a fraction, exhibit both of these properties. I'm going to have to look at the equality and when this expression, this fraction, is undefined. So first I'm going to deal with the equality one. So rather than looking at this less than or equal to, I'm just going to look at the equals part and find the critical number at the equality. So to solve this out, I'm going to multiply both sides by the LCD, which is x minus 5. It'll cancel out on the left. It'll end up with 3 times x minus 5 on the right. I'll then distribute that 3 and then combine like terms, and I'll get 8 is equal to x. So 8 is one of my critical numbers. The other critical value will occur when this entire expression is undefined. So the expression 2x minus 7 over x minus 5 will be undefined whenever the denominator is 0. So since the denominator is x minus 5, I'm basically looking for when x minus 5 is 0. So since the denominator is x minus 5, I'm basically looking for when the denominator x minus 5 is equal to 0, which occurs when x is equal to 5. So now that I have my two critical numbers, which are x is 8 and x is 5, I need to determine the solution to this inequality. So to determine that solution, I'm going to have to look at the intervals between these critical numbers. So to do that, I'm going to go to my number line and first mark my two critical numbers. Now, since 5 is less than 8, that will be the first one to my left. So I'm going to mark 5 on this number line, and I'm also going to mark 8 on this number line. So these two numbers are going to break this number line into three intervals. These are going to be values of x which are less than 5. In between here and here will be values of x which are greater than 5, but less than 8. And over here will be values of x which are greater than 8. So I'm looking at these three separate intervals, the ones between 5 and 8, the ones greater than 8, and the ones less than 5, and I'm going to use test points to figure out which of these intervals are included in this inequality. So the first number I can test, a number less than 5, a convenient or easy one would be 0. So I'm going to test x equals 0 into this inequality and see if it's true. So when I plug in 0, I'll get 2 times 0 minus 7 over 0 minus 5. 2 times 0 is 0, so I end up with negative 7, and 0 minus 5 is negative 5. So two negatives make a positive, so this is just 7/5. Now it might be helpful for me to estimate what 7/5 is, and it's approximately, or actually it is exactly equal to 1 2/5, which is 1.4. And since 1.4 is less than 3, which is what I'm testing, is this value less than or equal to 3? Since it's less than 3, it checks. Therefore, this interval is included in my solution. Okay, now I'm just going to erase this so that we can test another value. When you're doing your work, make sure you do not erase it, because that check is part of your work determining the answer to your solution. The next value I'm going to test is one between 5 and 8. So the number 6 would be a good test point between there. We already know that 0 works, so now we're going to test 6. So I'm going to take 6 and plug that into my expression. So I'll have 2 times 6 minus 7 over 6 minus 5. Well, 2 times 6 is 12, and 12 minus 7 is just 5. And 6 minus 5 is just 1, so this whole expression is just 5. But since 5 is not less than or equal to 3, it fails the test. Therefore, 6 is not a valid answer, and we would reject this interval. All of the points in this interval are not a solution to this inequality. So then the last one I have to test is values which are bigger than 8. So a convenient value, which is bigger than 8, would be 10. So I'm going to test 10 in this interval, since that's a number bigger than 8. And I'll get 2 times 10 minus 7 over 10 minus 5, plugging it into that expression. 2 times 10 is 20, minus 7 would be 13. 10 minus 5 is 5, which is equal to, when you divide 13 by 5, you'll get 2.6. And since that is less than or equal to 3, that checks. Therefore, this interval will also be included in my solution. And then the last thing I have to test are the 2 points themselves, those two critical values, 5 and 8. Well, notice that 5 was the solution to the undefined value. So if I was to plug 5 back in to this expression, I would get a denominator of 0, which makes it undefined. Well, undefined is an invalid solution, so 5 is not going to be included. So I'm going to throw an open circle on 5 to represent that it is not included. When I test 8, 8 was the solution to the equality. And since this is a less than or equals to, the equals value will be included in this inequality. Therefore, here at 8, the value 8 will be included in my solution. So if I was to graph this, I'm including the values less than 5, so that would be all of these values, but not including 5. And over here, I'm including 8 and all the values greater than 8. So since I'm including 8, I'm going to make this interval greater than or equal to. So my final answer as a graph would be this number line with one open circle and one closed circle, and I could represent the solution as a set of inequalities as all values of x less than 5, or all values of x which are greater than or equal to 8. And there's my final answer. So to sum up, every time you have a rational inequality, that is an inequality involving a fraction, you need to find the critical values. The critical values are where that expression is exactly equal to the other value on the side of the inequality, or when the entire expression itself is undefined. So once you have those two critical numbers, you can use a number line or just check the 3 intervals, find test points in each of those intervals, reject any ones which don't work, and accept any ones which do.